going with our geometric understanding, and we're really going to focus on angles in this one. Vertical angles are angles that are created by intersecting lines. So it's like they make an X. So when you see that X, they are going to have intersecting lines, and I'm going to know that angles 1 and 3 are vertical angles, but more importantly, 1 and 3 are going to be congruent, and angle 2 and 4 are going to also be considered vertical angles. So for the vertical angles, they need to be in an X, and they need to be across from one another. The sum of the measures of any two angles, if they are supplementary, is 180 degrees. Not every angle is going to be supplementary, but if it is supplementary and I add them together, it would equal 180. Complementary angles are similar, but in a complementary angle, they add together to be 90 degrees. We have other classifications of angles. If I have a transversal, which is any line that crosses two other lines, it forms a set of 8 angles. And I have interior angles, which means they're between the two lines. So 5, 6, 4, and 2 are between the two lines. I have exterior angles that are outside of the two lines. So 1, 3, 7, 8. I have alternate interior angles, which means they're opposite sides inside there, which would be like 5 and 2, 6 and 4. Then alternate exterior, opposite sides outside of my two lines, so 1 and 7, 3 and 8. And corresponding angles are in the same position. So you want to see it as two clusters of 4 angles. The angle 3 is in the upper left, so it corresponds to angle 4, which is in the upper left of that 4-angle cluster. So angles and parallel lines have several different properties. If I'm looking at two parallel lines in a transversal, I'm going to be able to give some basic congruency statements. So I know if I have a pair of corresponding angles, they're congruent. Alternate interior angles, congruent. Alternate exterior angles are also congruent. So if I wanted to construct this, which most of your students will not be constructing, we've kind of moved away from that, but I could actually construct my two parallel lines, and then I could start actually using a protractor to work with angles. We don't tend to do that a whole lot anymore, but they kind of take our word for it. So let's talk about triangles. Imagine if I have two parallel lines and I'm connecting a triangle inside of those two parallel lines. If that happens, the angles of all 3 angles inside that triangle are going to add to be 180 degrees. And if you look at angle 1, that is an alternate interior angle with the other angle 1. And the same thing is true with 3. 3 and 3 are going to be on alternate sides between the two lines. So let's look at an example here. In this framework, I have a tire jack, and the tire jack kind of forms this diamond that has parallel lines involved in it. And it measures 50 degrees. What are the measures of the other angles of the parallelogram? Well, if A, B, and DC are parallel, then I know that 50 is equal to 50 on the other side by angle 4, okay? If that is 50, the angle next to it has to add to be 180. It's supplementary. So I would have to have 130 plus 50 equals 180. So I know that angle 1 is going to be 130 because angle 1 and the angle next to 50 degrees are alternate interior angles, which also means angle 50 is going to be, angle 2 is going to be 50, and angle 3 is going to be 130 because our quadrilaterals, because they're encased in two parallel lines, are going to have opposite angles congruent. Here's another example. If I'm looking at this figure and I want to know why does the angle 1 plus angle 2 equal 180? Well, if I look at it, I have two parallel lines, and 1 and 3 are corresponding. They're both in the upper right. So if that's true, then angle 1 has to equal angle 3, okay? Which means that angle 2 and 3 are supplementary because they're on the same line. So if angles 2 and 3 are supplementary and angles 1 has to be supplementary as well, then I can say that angle 1 plus angle 2 also has to equal 180. This is a formula you need to take a minute to write down. This finds the sum, I'm emphasizing sum, of the interior angles of any convex polygon. So I'm going to do the number of sides minus 2 times 180. That's the total amount of degrees inside of an object. If I want just a single angle, if I want to know the measure of one exact angle, I'm going to take that formula and divide it by the number of sides. So if I have this shape, I have a pentagon, 5 sides, and the exterior angles are always going to be add to be 360, always. Interior angles, not going to be 360. Exterior angles, always going to be 360. So let's take a look at this. We know that a regular decagon has 10 sides from the slide I showed earlier with the names. So I'm going to do 10 minus 2 times 180, which is 1,440 degrees. If I wanted the measure of each angle, I would divide that by the number of sides, 10, to get 144. Now let's look at the number of sides of a regular polygon who has an interior angle measure of 175. Now I'm going to say, well, if I know it's 175, and that's going to be the interior angle, each exterior angle would be 180 minus 175, which is 5 degrees. So if I take 360 and I divide it by that 5 degrees, I have 72 exterior angles. So there are 72 sides. You could also set 175 equal to n minus 2 over n times 180 as well. That would just get you a lot harder with algebra. Here, if I have lines L and K and they're parallel, and I want to find the angles for A and B, and I want to find angle X, the measure of BCA. Imagine if you extend that angle until you get a triangle. Once we have this triangle, we know some measurements that are key in the triangle. So to find angle C at the top of the triangle, I would simply need to work with 180 minus my 2 angles. Then to find angle X, that's a linear pair. So I'm going to do 180 minus the measure of the angle inside the triangle, and that's going to give me the value for X, which is 140.